So, what's an architecturally significant requirement, or ASR? Sounds fancy, but not so much. Put simply, an ASR is any requirement that can have a profound effect on your system's architecture. Any requirement. Okay, but how's that different from what we already refer to as quality attributes, non functional requirements, ilities, constraints, technical requirements, etc., etc.? Why are you making me learn a new word? Well, it's subtle. Let's break it down. ASRs are a sort of superset or umbrella of any kind of requirement that has an effect on the shape of your system. They're requirements that point us towards how we want to build the thing. Without ASRs, we could develop software any number of ways. Without ASRs, there would be no wrong way to write code. There'd be no trade-offs or consequences. All right, so let's dig into the kinds of requirements that make up an ASR. First, let's start with functional requirements. These are the requirements that tell us what we want the system to do. Typically, these requirements include the who, the what, and the why. That's who we're building the thing for, the persona, what it is we're building, the system's behavior, and why we're building it, the expected outcome for when we build the thing. Let's try it out. As a student, I want to be able to order textbooks so that I may do my class assignments. As a patient, I want to see the results of my lab work so that I can discuss possible treatments with my physician. As a software developer, I want to compile my code so that I can run my program. You might not always get requirements that are so cut and dry. You're going to have to collaborate with the requirements engineer or your stakeholders to flesh them out. For the most part, functional requirements don't dictate the architecture. But an architect's got to make a decision about which part of the system is responsible for that new functionality. If you got a monolith, no big deal. Just plop it into the big box. We'll deal with maintaining that beast later. If you've already got a modular or distributed system, you'll have to figure out which part of the system you're going to crack open and change. Beyond that, an architect needs to take a close look at each functional requirement and think about how it's going to affect the other qualities of the system. For example, you want to add functionality that pulls in data from Texas to Turkey? Well, that's definitely going to impact your system's performance. And that leads me to the second kind of requirement that makes up our ASRs, quality attribute requirements. We sometimes call those non-functional requirements. These are the requirements that qualify the functional requirements or the overall system. In other words, if a functional requirement describes what the system is supposed to do, the quality attribute requirement describes the way in which the system is supposed to do it. It's the desired property or quality of the system. Let me give you an example. As a student, I want to be able to order textbooks reliably so that I can be sure to get my books on time before class starts. As a patient, I want to see the results of my lab work securely so other patients can't see my test results. I want to keep that information private. As a software developer, I want to compile my code quickly so that I can execute my unit tests seamlessly. Test-driven development, baby. Now, this is where it gets interesting. There's two kinds of quality attributes. First, there's the kind like I was just talking about, those that describe how the system behaves while it's running. But then there's the kind that describe how we're going to actually develop the system. That's right. In this case, the who can be the developers, system administrators, or the folks in operation. Here we go. As a developer, I want to be able to make changes to the software easily so that I can keep the costs of adding new functionality down to a minimum. As a system administrator, I'd like to be able to configure the deployed system efficiently so that I can keep downtime to a minimum when I upgrade the system. As someone monitoring the system at runtime, I'd like to receive notifications when the system goes down instantly so I can fix the problem as quickly as possible. Now, the examples I just gave aren't so good. Why is that? Quality attribute requirements have got to be crystal clear and testable. I'm going to say that again for the folks in the back. Quality attribute requirements have got to be crystal clear and testable. Here's an example of a better quality attribute requirement. As someone monitoring the system at runtime, I'd like to receive notifications when the system goes down within 3 seconds so I can fix the problem as quickly as possible. That's a measurable outcome. And more importantly, it's testable. If I create a test that simulates the system going down and it takes 4 seconds for me to receive a notification, well, the test failed. Go fix it. Okay, but what if we're faced with a situation where some of the desired qualities of a system seem to contradict one another, like a tug of war? Sometimes, the more we develop a system to have one quality, the more we pull the design away from another quality. For example, remember that security, functionality, usability triangle? The more secure a system is, the less user-friendly and functional it is. The more functionality you throw at a system, the more confusing and less secure it's going to be. Or how about that CAP theorem? If your distributed system suffers from partitioning, then you've got to choose between consistency and availability, unless you build a wormhole. It's not possible for everyone in the world to see your Instagram pics instantly and all at the same time. Quality attributes come with trade-offs. Different architecture patterns favor different qualities. Modular monoliths are fairly simple and cheap to develop, but they're not very elastic or scalable. On the other hand, microservices are super elastic and scalable, but complicated and expensive. Pick your poison. At the end of the day, the architect has the difficult job of making a decision. They have to determine which trade-offs are acceptable for the system they're designing, and those decisions stick around for a long time. And that brings us to the third and final kind of requirement that makes up an ASR: constraints. A constraint is a design decision that's already been made for you. Usually, these design decisions are the ones made by other architects working on the system before you came along, or worse, it's the emergent architecture that just happened when developers wrote code without guidance of an architect. When designing changes to an existing system, you have to decide if you're going to slide the new functionality in like a perfectly fitting puzzle piece, or if you're going to have to take a sledgehammer to the existing code. Be careful. Each choice comes with their own trade-offs. Sometimes design decisions aren't made by architects or developers at all. Politics. Maybe your hands are tied and you're forced to implement a technical approach because of a super secret backroom deal that you don't know nothing about. Maybe the organization accepted the trade-off to use a difficult to implement service in exchange for a business partnership that's going to make us all the money. Of course, then there are those pesky universal constants holding us back, right? No matter how much you grease the electrons, you'll never be able to post an HTTP request to your server faster than the speed of light. These constraints affect the design of our system. If we're lucky, we can come up with a workaround or mitigation for some of those constraint-imposed trade-offs. Systems offline? Maybe distract the user with a little video game, a pixelated Tyrannosaurus Rex side-scrolling through the desert hopping over cactuses. When you lump it all together, it gets real clear. The task of identifying architecturally significant requirements ain't so easy. No one's going to deliver these requirements to you on a silver platter. You're going to have to put on your hard hat and go spelunky. This means that an architect needs to start collaborating with their requirements engineers and product folk early, while those user stories and functional requirements are just beginning to get fleshed out. An architect needs to go make best friends out of their stakeholders. Find out what they're not telling you. What are their pain points? What's the real reason they're asking for that new feature? Don't be afraid to practice the 5 whys method of root cause analysis. What's more, an architect's got to be aware of their organization's own business strategic goals. Does your company have a goal to release products with 0 defects? Do they want to migrate their solutions to the cloud and save on infrastructure costs? Maybe they want to foster better collaboration between their teams working on interdependent components. Once you're able to identify and articulate those requirements, those testable requirements, then and only then can you start to evaluate your options and make an informed architectural decision.